Hello, boys and girls. This is Mrs. Bandu's Math Movies. We are looking at Course 2, Lesson 5.5 for my Period 4 class using similar figures. We are going to use proportions to find missing lengths in similar figures. Okay, so we do have a couple of definitions here, and the first one is similar polygons. Two polygons are similar if corresponding angles have the same measure which basically means that they're equal, and the lengths of corresponding sides form equivalent ratios. Or they're proportional. Remember, corresponding means matching things up. So when we start looking at pictures or figures, we'll talk about how we can do that. We have a couple of other definitions. One is a polygon, and a polygon is a closed plane figure formed by three or more line segments that do not cross. Okay, they'll meet, but they won't cross each other. Okay. Oops. And indirect measurements is basically using proportions and similar figures to measure distances that are difficult to measure directly. Okay, so this might be the distance across a pond or the height of a tree or something like that, where we can find something smaller, easier to measure, and compare that to a larger similar figure, and we can go from there and use that idea to find missing parts. Okay, let's look at our examples. Finding a missing measure. Triangle ABC, which is the smaller one over here, and triangle DEF are similar. Find the value of C. So I'm looking for the length of side C. Alright, now since I know that my triangles are similar, I'm going to use a little trick here to help me be sure that I'm going to match things up carefully. And when you have a statement that things are similar, this is when we talk about A, it matches with angle D. So A and D are corresponding angles. B matches E, so they are corresponding angles. And C matches F, so they are corresponding angles. And I'll use this idea also when I'm trying to pick out corresponding parts. Okay, so segment AB, which is the length of is C, okay, corresponds to DE. And DE has a length of 18. So I'm going to substitute that number in for DE. Segment AC, right here, is 6. It corresponds to segment DF. So DF is 9. So I'm going to fill that in with a 9. Okay. At this point, in this example, they're asking you to write 6/9 in simplest form, which is 2/3. You don't absolutely have to do that. It can make your math a little bit easier, but it's okay if you don't. Since they had asked us to do it, we'll do it. Okay? All right. So find the common multiplier. And so I'm going to go where I have an 18 on the bottom and a 3 on the bottom. So 3 times 6 is 18. 2 times 6 gives me the value for 12. So 12 is my missing value. So the length of C is 12. 12 units. It doesn't really give us the unit in which it's measured. Okay? Those numbers were easy enough. They were a mental math problem. Okay, let's look at the next one. And this is comparing something you know about a person to something about a tree. A 5-foot person standing near a tree has a shadow that is 12 feet long. So that's what this triangle here represents. Here's the person, 5 feet tall, shadow of 12 feet. Now that gives you 2 parts, 2 sides, and I can connect those and make a triangle. So I'm going to be looking at similar triangles. At the same time, the tree, which I don't know how tall it is, has a shadow 42 feet long. What is the height of the tree? And it's given you some choices here. So draw a picture and let X represent the height of the tree. So that picture's already been drawn for you, but on a problem like this, I do highly recommend that you draw something so that you have a picture in front of you and you can know what things need to be partnered up. Okay, so what I've done here, or what the authors have done here, they've taken the object, the tree, and compared it to the person. So tree to person. Go back and get the shadow of the tree to the shadow of the person. Okay, so however you set up your first ratio, you must follow the same procedure to set up your second ratio. So the X and 42 both came from the larger triangle. 5 and 12 came from the smaller triangle. Okay, write a proportion, which we just did, and find the cross product. So X times 12 is 12X. And then we're going to multiply 5 times 42. Okay, I'm going to mark that out right here and jot in the number which it is equal to. Its product is 210. Okay, so you're going to get 12X equals 210, and then we're going to solve for X by dividing each side by 12. So 210 divided by 12, if you'll put that in your calculator, you should get 17.5. That tells us that the tree is 17.5 feet tall, and the correct answer choice from above is choice A. Okay, and again, you can always double check yourself. Take 17.5 times 12, and that should equal 210, because 5 times 42 equals 210. All right, there are a couple of questions, quick checks for you to answer. Again, as always, please write down your work so that we can talk about what you did and did not understand, and gives us a starting point for our class discussions. I look forward to seeing you soon. Bye now.